The microwave oven was never supposed to exist. No one sat down and asked, how can we cook food with invisible waves? No chef imagined it. No kitchen engineer designed it. It began with war. During World War II, scientists were racing to improve radar technology. Radar was critical. It could detect enemy aircraft and ships using radio waves. The stronger and more precise the radar, the greater the advantage. One of the companies deeply involved in this research was Raytheon, and one of the engineers working on radar systems was Percy Spencer. Spencer was not a formally trained academic. He was largely self-taught, a practical engineer who understood machinery intuitively. His focus was not food. It was magnetrons, powerful vacuum tubes that generated microwave radiation for radar. The goal was simple: make radar more efficient. Magnetrons produced high-frequency radio waves. When powered, they emitted intense microwave radiation, invisible, silent, and, at the time, poorly understood outside military research. One day in 1945, while standing near an active radar set, Spencer noticed something strange. A chocolate bar in his pocket had melted. He hadn't been near a stove. The room wasn't hot. Nothing else seemed unusual. But the candy had turned soft and sticky.
For most people, this would have been dismissed as an inconvenience. Spencer saw a question.
He suspected the magnetron was responsible.
Microwaves, the same waves used to detect aircraft, had somehow transferred energy to the chocolate.
Instead of ignoring the anomaly, he decided to test it. He placed popcorn kernels near the magnetron. They exploded. Then he tried an egg. The egg reportedly burst, spraying hot contents across the face of a colleague who leaned too close. The reaction was sudden and violent. The pattern was undeniable. Microwave radiation could heat food rapidly and directly, not by warming the surrounding air, not by heating a surface, but by exciting water molecules inside the food itself. This was the breakthrough. Traditional ovens heat from the outside in. Air warms the exterior of food, and heat gradually travels inward. It's slow, energy-intensive, and inefficient. Microwaves work differently. They penetrate food and cause water molecules to vibrate. That vibration generates heat from within. Cooking becomes faster, more direct, almost surgical. What began as a radar experiment suddenly looked like a kitchen revolution. But revolutions don't happen overnight. Raytheon recognized the potential and filed patents. In 1947, they introduced the first commercial microwave oven. It was called the Rataranj. It was enormous, nearly 6 feet tall. Weighing over 700 pounds, water-cooled, expensive, industrial, it was not designed for homes. It was installed in restaurants, ships, and commercial kitchens. The idea of cooking with radiation unsettled people. The word itself carried fear. Invisible waves altering food? It sounded unnatural, possibly dangerous. And yet the physics was sound. Microwaves do not make food radioactive. They simply transfer energy. Once the waves stop, the energy transfer stops. No residue, no lingering radiation. Still, public adoption was slow. It took decades for microwaves to shrink, become affordable, and enter homes. By the 1970s and 1980s, the microwave oven transformed kitchens worldwide. Leftovers reheated in minutes. Frozen meals became viable. Time in the kitchen shortened dramatically. The accident had matured into infrastructure. But the deeper story is not about convenience, it's about attention. Percy Spencer could have ignored the melted chocolate. It was a minor anomaly during wartime research. There was pressure to improve radar, not experiment with snacks. Yet curiosity overruled routine. He didn't just notice something unusual, he tested it, repeated it, confirmed it. Accidental inventions rarely happen because of chaos alone. They happen because someone chooses to investigate the unexpected. The magnetron was not designed to cook. The radar lab was not a kitchen. The goal was detection, not dinner. But innovation often occurs at the edges of purpose. A tool built for one objective reveals a property useful for another. The history of technology is filled with these sideways discoveries. Adhesives that fail become post-it notes. Mold contamination becomes penicillin. Radar tubes become microwave ovens. The microwave reminds us that invention is rarely linear. Progress does not always follow intention. Sometimes the most transformative technologies emerge not from planning, but from interruption. A melted chocolate bar forced a question.
A question led to experimentation. Experimentation led to a patent.
And a patent reshaped daily life. Today, the microwave is so ordinary it barely registers as technology. It hums quietly in the background of modern living. But its origin is anything but ordinary. It represents a moment when military research collided with domestic life. When invisible waves leapt from battlefields to kitchens. When an engineer allowed curiosity to interrupt urgency. If Percy Spencer had brushed off the melted chocolate, the microwave might have been delayed for years, or discovered by someone else entirely. History often pivots on small decisions. Notice or ignore. Question or dismiss. The radar experiment did not set out to change how the world eats. It changed it anyway. Accidental inventions are not accidents in the pure sense. They are intersections, where preparation meets surprise. The magnetron existed because of war. The microwave oven exists because of curiosity. And that difference matters. If you enjoy the accidental, unexpected, and human side of technology, subscribe to Talking Tech for more documentary-style tech stories.